Let's look at exercise 2.1.23. Determine whether the set of vectors is dependent or independent, given a set of three vectors in R3. Still in section 2.1, the equipment we have, let's take a look at the notes. That's relevant is finding a basis for a span of a set of vectors. So we'll take those three vectors, put them in a matrix A as columns, row reduce, we'll let Wolfram alpha do the row reduction, and then look for pivots in the row reduced version of matrix A. That'll give us a basis for the span of that set. And a basis is a linearly independent set, so that'll allow us to determine linear dependence or independence. So we apply theorem 2.1.A and consider a matrix that has these vectors as its columns. In essence, what we're finding is a basis for the column space of matrix A. Let's let Wolfram alpha do the row reduction. And what Wolfram alpha will give us is the following. We'll call that matrix H. So we've got a matrix with a pivot in the first column, a pivot in the second column, and no pivot in the third column. So that tells us, with strict application of theorem 2.1.A, a basis for the span is, bases are sets, a set consisting of first column, first vector, second column, second vector. We were given those as row vectors, so we'll write them as row vectors. So we get the first vector 1, negative 4, 3. Second vector 3, negative 11, 2. So there's a basis for the subspace spanned by those three vectors, but that wasn't exactly the question. The question is one of linear dependence or independence. A basis is a linearly independent spanning set. So a basis is, by definition, a linearly independent spanning set. Hence, the set consisting of just the first two vectors is a linearly independent set, is an independent set, to abbreviate a little. So it must be the case that the third vector is a linear combination of the first two. We don't need the third vector as an element of a spanning set. This is a basis, so this is a spanning set. So that is the third vector let's see, vector 1, negative 3, negative 4 is a linear combination of the first two. So we don't have a linearly independent set of three vectors. We have a set of three vectors, the first two of which spans the same set spanned by all three of them. So the given set of three vectors is linearly dependent. So even though we had equipment to deal with only finding bases for spans of sets of vectors, it's sufficient equipment to check to see if a set of vectors is linearly dependent or independent. Had we had pivots in each of the columns, each of the vectors would have been required to make a basis for the span of this particular set of vectors, and that would have been a situation where the vectors determine a basis, so the vectors determine a linearly independent set.